Hello everyone. Today in Unit 4 Laser and Fiber Optics, we will discuss the topic Ruby laser. So there are different types of laser systems here on the basis of active medium. First one is solid state laser. The example is Ruby laser. Second is a gas laser. Example for gas is helium neon laser. And the third one is semiconductor laser, that is gallium arsenide laser. Now today we will discuss the Ruby laser system. So a Ruby laser is a 3-level laser system here. It is being demonstrated by Myanmar, and the output from the Ruby laser we will get as a pulse laser here, and it is used in various industrial applications for hard facing like surface hardening, and it has a high power laser which has hundreds of milliwatt. Now we need some source of energy, a pumping source for the excitation, so that we use in Ruby laser xenon flash lamp. And active medium, we have seen the definition. Active medium is the medium in which the population inversion takes place here. So active medium in Ruby laser is Al2O3 doped with 0.05% of chromium ions here. The next is active element or active center, that is chromium is the active center in Ruby laser. That is the atoms or the molecules which are responsible for the population inversion is called active element or center. So in Ruby laser, chromium ions is responsible for the population inversion. The next term is optical resonator here. Optical resonator, we have arrangement of one end of the face we have the 100% silvered mirror and other end partially silvered mirror here. So let us go into the construction here. This is the construction of a Ruby laser here. So we have a Ruby rod, a cylindrical rod, which is having the composition of Al2O3 and 0.05% of chromium ions here. So the ends of the Ruby rod are polished such a way that it is act as an optical resonator. One end as a 100% silver and other as a partially silver. So it acts as an optical resonator. So we have a xenon flash tube here. This is your helical flash tube. It is arranged in such a way that only a green light of wavelength 5600 is supplied here to the active medium. Okay, now when a part of the flashlight is used for the pumping, then the chromium ions will get excited in this here. So a cooling arrangement is made here in order to avoid the overheating of the apparatus. Now this is the working principle. So this is an example for a 3-level laser system here. So we have E1 ground state, E2, E3 are the excited state here. So immediately when you are given a xenon flash lamp, a pumping source here, so the ions, the chromium ions will get excited and they go to the energy level E2 and E3 here, E2 and E3, where E2, E3 are the excited energy level and E2 is a metastable state here. So what is the metastable state? It is the state which has more lifetime than the excited state here. So immediately when you are given the xenon flash lamp in pumping source, the chromium ions will get excited to the E2 and E3 here. As E3 is an excited state here, immediately it will get decay to E2 energy level. So it is a continuous pumping system. Continuously we are pumping the atom chromium ions to E1 from E1 to E2, E3, and immediately it get decays to E2 here. So this is a continuous here. So when you see here, when we observe here, at particular here, E2 as it is a metastable state, we can get a condition that we can have more number of atoms at E2 energy level than E1 energy level. That is the condition of population inversion, that is N2 greater than N1. Yes. So we are getting the condition of population inversion between this E2 and E1 here. So we are having more number of atoms at E2 than E1 here. So atoms come from E2 to E1 by the spontaneous emission and again by stimulated emission from E2 to E1 here. So whatever the photons which are being emitted here, they will travel through the Ruby rod and it is moving parallel to the axis of the crystal and will just reflected between the partially silvered and fully silvered here, such that it can emit a fresh photon which is in phase with the earlier photon here. So this process is repeated again and again because the photon repeatedly move along the crystal being reflected from the ends here. So then the multiplication of the photon will takes place. That is a laser process will takes place. So when the photon beam becomes sufficiently intense such that a part of it emerges through the partially silvered end of the crystal. Finally, a ruby laser emits a wavelength around 6943 angstroms. Thank you.